Hello and welcome to this GCSE Science Core Chemistry revision video on metals. In this video we will cover extracting metals, iron and steel, aluminium and titanium and copper. When extracting metals we must consider their reactivity and in terms of reactivity series. In your exam, on the back of your periodic table sheet, you will have a reactivity series given to you. Metals are produced when metal oxides are reduced, so have their oxygen removed. The reduction method depends on the reactivity of the metal. For example, aluminium and other reactive metals are extracted by electrolysis, while iron and other less reactive metals may be extracted by the reaction with carbon or carbon monoxide. This is because they are less reactive than carbon. Gold, because it's so unreactive, is found in the native metal form and not as a compound. It does not need to be chemically extracted from its ore, but chemical reactions may be needed to remove other elements that might contaminate it. The reactivity series shows the order of metals going from most reactive at the top to least reactive at the bottom. The more reactive metals have a greater tendency to lose electrons and form positive ions. Iron is extracted from iron ore in a huge container called a blast furnace. Iron ores, such as hematite, contain iron oxide. The oxygen, therefore, must be removed from the iron oxide to leave the iron behind. Reactions in which oxygen is removed are called reduction reactions. This diagram shows a blast furnace. Into the top, we load in the iron oxide. We heat it to a high temperature. We blast in hot air from the bottom. By blasting in hot air at the bottom, it provides the extra oxygen needed to convert any carbon monoxide formed into carbon dioxide. It also needs to be done at a high temperature, and limestone may be added to absorb impurities. Carbon is more reactive than iron, so it can push out or displace the iron from iron oxide. So the equation for this is iron oxide plus carbon goes to form iron plus carbon dioxide. In steel, carbon is removed from molten iron by blowing oxygen through it. The oxygen with the carbon producing carbon monoxide and carbon dioxide, which escape from the molten metal. Enough oxygen is used to achieve steel with the desired carbon content. So, in other words, not all of the carbon is removed from the iron. Other metals, such as vanadium and chromium, are often added to the steel to change its properties depending on what it needs to do. The properties of a metal are changed by adding other elements to it. A mixture of two or more elements where at least one element is a metal is called an alloy. Alloys contain atoms of different sizes which distort the regular arrangement of the atoms. This makes it more difficult for the layers to slide over each other, so therefore alloys are often much harder than their original metal. Aluminium is a reactive metal, so can't be extracted using carbon, but electrolysis is used instead. Electrolysis involves an electric current passing through molten aluminium oxide at a high temperature. Before electrolysis can take place, the aluminium ore needs to be purified into pure aluminium oxide so impurities are removed. A very high temperature is needed to melt aluminium oxide, and a lot of electricity is needed to extract the aluminium. Some of the reasons why aluminium is useful is that it does not corrode. Aluminium or alloys of aluminium have a very low density and are much stronger than pure aluminium. Because aluminium is light, it can be used for things like aircrafts and such forth, where you need the metal to be strong but also light. Due to aluminium being extracted using electrolysis, it is very expensive to extract, which is why recycling aluminium is often a much more desirable need. Titanium is not very reactive, so we could use carbon to displace it from its oxygen, but carbon reacts with titanium, making it very brittle. To stop this happening, we need to use magnesium or sodium to displace the titanium, but these have to be extracted by electrolysis first. Due to this electrolysis, this is what makes titanium very expensive. Titanium oxide needs to be converted into titanium chloride, which is then distilled to purify it. After this process, it can then be displaced using sodium or magnesium. Titanium has a range of uses because titanium is very strong and resistant to corrosion. It has a high melting point, and its common uses are in jet parts, sports equipment, replacement hip joints, and nuclear reactive parts. Due to titanium needing lots of stages to extract it, it is very expensive. Some copper ores are rich in copper. They have a high concentration of copper compounds such as copper sulfate or copper oxide. Copper can be extracted from these ores by heating them in a furnace in a process called smelting. The copper is then purified using a process called electrolysis. Electricity is passed through a solution of copper compounds such as copper sulfate. During electrolysis, positively charged copper ions move towards the negative electrode and are deposited. The process of smelting follows the following stages. First, the copper is dug up and crushed. The copper ore is then roasted to leave copper oxide. This releases sulfur and carbon dioxide into the atmosphere. Carbon is added to the copper oxide. They are heated together. Because carbon is more reactive than copper oxide, the carbon reduces it, so we're left with copper. Copper is purified by electrolysis, as previously stated. The impure copper is connected to the positive electrode. This gives the copper ions a positive charge. These positive copper ions then move through a solution of copper sulfate to the negative electrode, where they become pure copper atoms. The impurities drop down from the positive electrode and are left as a sludge at the bottom of the reacting vessel. Another way of getting copper ions is by photomining and bioleaching. Some plants absorb copper compounds through their roots. They concentrate these compounds as a result of this. The plant can then be burned to produce an ash that contains copper compounds. This method of extraction is called phytomining. Another method is to use bacteria in a process called bioleaching. Some bacteria absorb copper compounds. They then produce solutions called leaches, which contain these copper compounds. Copper can then be extracted by filtering this solution. The final way that copper can be produced is using scrap iron. Iron is more reactive than copper, so can be used to displace copper ions from copper salts. For example, iron plus copper sulfate will go to form iron sulfate plus copper. To finish off, when you're revising, make sure that you don't have any distractions. Make sure that you're doing it earlier in the day, as your brain will be more active. And remember, quality revision is better than quantity of revision. Please have a look at my other chemistry videos to help you with the other areas in the chemistry GCSE. Good luck with your exams.